Okay, 1-1, variables and expressions. First definition, we have several definitions in here, is quantity. A quantity is, oops, get this thing to work here. Quantity is anything that can be measured or counted. So quantity is anything that can be measured or counted. A variable is a symbol, usually a letter, like X or A or B, that represents the value of a variable quantity. Algebraic expression is a mathematical phrase that includes one or more variables. We're going to be writing algebraic expressions today. Numerical expression is a mathematical phrase involving numbers and operations, but no variables. That's what we've been doing. I'll give you a minute to write those down, and then we'll do some examples of some algebraic expressions. We're going to write some from sentences or phrases. All right. Go ahead and move on here. All right, a word phrase. It says 32 more than a number. These are word phrases that have addition or subtraction in them. When you see the phrase more than, that means addition. When you have the more with the then or the less with the then, you usually put the number at the end of the phrase. And so it would look like this. X. Let me be able to get this to work here. It's just not going to work here for me. It should be X plus and then 32. 58 less than the number Y would be Y, and the less than says minus, and then 58, so that more than or less than works the same way. So more than is addition, less than subtraction. 12 less than a number P would just be P minus 12. Right, so writing expressions with multiplication and division. So here's some multiplication and division expressions. 8 times a number M. 8 times the number M is definitely multiplication. You just write it as 8, and then right next to it, the M. The quotient of a number Y and 5. Quotient means division. So a quotient of a number Y and 5, we take the Y because it comes first. When you see the phrase quotient or word quotient, you just take it in order. Quotient of a number Y and 5, the Y goes on the top, the 5 goes on the bottom. If it said the quotient of 5 and a number Y, the 5 would be on top and the Y on bottom. So it's whatever comes first in that phrase after the word quotient goes on the top of the fraction. All right. Writing expressions with 2 operations. This is a combination of the 2 we just did. 3 more than, twice the number X. So we're going to start on this side over here with twice the number X and do that first because of the more than phrase. More than is going to take whatever is more than and put it on the other side. So it'll be plus 3 on the right hand side, on the end of the phrase. So twice the number X, and then we'll do that first. That's the 2X part right here. And then the more than part is the addition sign right here. All right, 9 less than the quotient of 6 and a number V. So we're going to do quotient of 6 and a number V first, So it's 6 over v. That first quotient of 6 and a number v. 9 less than, we put the minus 9 at the end. All right. Give you a minute to copy that down, or a few seconds actually to copy that down. There'll be several other examples like that in the classwork. All right. Now, one more short little page here. Right, using words for an expression. What word phrase represents the algebraic expression? Okay, so these we're going in reverse. So 3x, there's lots of different ways you could write that. You could write it as 3 times the number x, if you were to follow the example from the previous page, or 3 times x, or the product of 3 and x. There's more than one way to write that. But 3x, you could just write 3 times the number x for that. 3 times a number x. It'll look like this. Or 3 times a number x. Y plus 8.1 might be 8.1 more than a number y. And then the last one on there is a combination. I would say it's 6 less than the product of 10 and d, or 6 less than 10 times the number d. Either one would be correct. 6 less than 10 times a number d. So that's going the other direction. We give you the algebraic expression, you express what it says in words. All right, write in a rule to describe a pattern. The table and picture below show how the height of the house of cards depends on the number of levels. So we see at level 2, 3.5 times 2 would be 7, plus 24 is 31. So right here we have 31 is our first one. 31 is the height in inches. The second one is 3.5 times 3, so if you added 3.5 more to 7, you get 10.5 plus 24. 10.5 plus 24 is 34.5. And then the last one would be 3.5 times 4, which is 14 plus 24 is 38. So you'll notice here it's going up by 3.5 each time. So my rule is you're going to multiply the number of levels, which in this case is n, so put an n in place of the 4, and then multiply that times 3.5. 3.5 times n, and then add 24 to it, and that is the general rule. So it's called an algebraic expression. Set it equal to y, that would be your algebraic equation that would model the height of the cards as you build one row to the next, the number of levels from one level to the next. So that would be my rule as an algebraic expression to finish the table. So my rule is 3.5n, so one more time, 3.5, and I'm just writing down the same thing I have just up above, plus 24, and I'm writing 3.5 next to the n to represent that you multiply the number of levels times 3.5 and then add 24. Now the way I'd use the rule is, how tall would the tower be if there were 10 levels? That would be 3.5 times 10 and plus 24. 3.5 times 10 would be 35, plus 24 would be 59. So it would be 59 inches. What would the rule look like if each card was 5 inches tall? So in the one up above, it says the height of the card is 3.5 inches. You can see it over here. If we switch it to 5 inches, the rule would just change right here. You would have 5 times n plus 24 instead of 3.5 times n. That's the only change. So I hope this helps. Thanks for watching.